greatest integer of x plus 2. All right. So everybody better be paying attention to what the problems I'm working today. I'm doing this to help you review, so make sure you're staying with me and asking questions when you need to. With the greatest integers, we know that it is a step function. So we had to get one complete step, and then we could just follow the pattern from there. Typically, to get one complete step, you have to plug in some decimals. So we usually have to do like maybe 0, 0.5, 0.9, and 1. That one on the homework was kind of the exception. You did those and you kept getting the same answer, so you had to keep plugging in some bigger numbers. So if I put in 0, 0 plus 2 is 2. Greatest integer of 2 is still 2. So I got out that integer. That is the beginning of a step. Now we need to figure out where that step ends. So we keep plugging in. If I put in 0.5, I get the greatest integer of 2.5. What is the greatest integer of 2.5?
2.
So 0.5 gave me 2. If I put in 0.9, I get the greatest integer of 2.9, which is 2. When I put in 1, 1 plus 2 is 3. Greatest integer of 3 is 3. So when I put in 1, that's when it jumps up to the next step. So we had to put an open circle underneath. So now I know what my steps look like. I always told you you needed a minimum of 3. So we can see it's closed on the left, open on the right, and then it jumps up 1. You could go backwards if you wanted. I will just require at least 3. You could always do more. And then we just usually did the dot, dot, dot to show ourselves that it kept going. That wasn't really it. That was just a portion of the graph. All right. Is that one okay? So next one. Number 7. We have f of x equals 3 times the square root of x minus 2. On this, I will require a parent function and transformations. So your parent function is just your square root of x. So you have to think about numbers you can plug in. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. So there's my graph. What does the minus 2 do?
Right 2.
And what is the 3?
Stretch.
Okay. Outside is y and it does what you think. So that stretch, if you just took these ordered pairs that we have, the stretching part is just taking their y value times 3. So 0 times 3 is still 0. 1 times 3 is 3. 2 times 3 is 6. Okay, then if I take these new points, that's the stretch, and then we still have to move it right 2. So 1, 1 turned into 1, 3, and then you go right 2. 4, 2 would turn into 4, 6, and then you go right 2. So we see our new graph. When in doubt, if you're really confused, you could always just plug some numbers into this original. You know, if I plug a 2 in up here, I get the square root of 0 times 3, which is 0. If I plug a 3 in up here, I get the square root of 1, which is 1, times 3 is 3. If I plug a 6 in, I get the square root of 4, so 2 times 3 is 6. So you can always double check yourself. You can also graph it on your graphing calculator just to make sure that your shape matches. So I require you to plot your points exactly on your graph, but you have a lot of options for checking those points and making sure that you've done it correctly. Is that one okay? If you have any mistakes on your study guide, make sure you are fixing them as we go through here. So number 8. So for this one, we would need to do what?
T-charts.
T-chart for each piece. So the first one has to start at -4, but it didn't have an equal to, so that would be open. And then we need things less than that, so maybe a -5 and a -6. So if you plug in -4, 2 plus -4 is -2. 2 plus -5 is -3. 2 plus -6 is -4. So -4, -2 is open. -5, -3. -6, -4. So that piece looks like that. For the middle piece, what do we have to plug in?
Both numbers.
Then you could do something in the middle. The -4 had an equal to, so that one's closed, but the 2 did not, so it will be open. And you get out the opposite of x. So opposite of -4 is +4, opposite of 0 is 0, opposite of 2 is -2. So -4, 4, 0, 0, 2, -2 is open. Because it had 2 endpoints, it doesn't extend either direction. That's just where it starts and stops. Final one, you have to put in 2 to begin, and then you need things greater than that. It had an equal to, so it would be closed. So 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. 2, 6 is closed. 9, and it just keeps going that way. Make sure you know how to graph these piecewise. There will be at least one on your test, and they are worth several points because you have to graph each piece. I'm looking at the correct open versus closed circles, the correct lines for each piece. Is that okay? Problem 11. This means f times g. So f is 3x squared minus 2. G is 4x plus 4. So how do you multiply those? 4. So we get 12x to the third plus 12x squared minus 8x minus 8. There are no like terms, so we're done. Number 14 asks for the domain of g divided by f. So g divided by f, that's 4x plus 4 over 3x squared minus 2. If you have a fraction, how do you find the domain? The bottom cannot equal 0. So if we solve that, divide by 3. To get rid of a square, we do the square root. When you add a square root, you also need plus and minus. So you get the x cannot equal positive or negative square root of 2 over 3. Another way of writing that if you chose to get the radical off the bottom, if you multiplied that radical 3 on top and bottom, you get plus and minus radical 6 over 3. So those answers are equivalent, just a couple ways of writing the same thing. Everybody with me? Alright, so you guys were good on the rest of those there in that section? So you guys got number 16, f of x plus h minus f of x over h? Okay, let's look at that real quick, and then we'll go to 17. Okay, when I had you do these, I always kind of broke it up into pieces. So that is probably how I would ask it on the test. I'm not just going to say do everything at once. So I would ask an ABC question. So part A, I would say tell me f of x plus h. So that means you go to your function, you replace your x with x plus h. Now, if you have that x plus h squared, what do you need to do? FOIL it. Means you have 2 of those. So you get 3 times. So that would be x squared plus xh plus xh is 2xh plus h squared. So then if we distribute, we get 3x squared plus 6xh plus 3h squared minus 2. Then I would say on part B, give me f of x plus h minus f of x. F of x plus h is what you just got. And you need to subtract off f of x, which is the original problem. So what do you need to do?
Distribute them over
So then the 3x squareds cancel, the 2's cancel, and you get 6xh plus 3h squared. And then on part C, I would finally ask for the full thing. All of that divided by h. So you take your answer divided by h. So if you cancel an h out of everything, you get 6x plus 3h. So that was the final answer. On the study guide, I just asked for it all at once, but on the test, I will say, part A, do this, part B, do this, part C, put it all together. All right, everybody got that corrected if you missed it? Let's talk about number 7. Or sorry, 17. So that D just represents domain. So in part A, I asked for D of f. That means the domain of f. F is negative 2 over x minus 5. If you have a fraction, how do you find the domain? The bottom cannot equal 0. I do expect that in interval notation. So we know x can't be 5, so you would have to write negative infinity to 5, union 5 to infinity. All right, we didn't ask about B, but you guys tell me. How am I going to do part B?
X plus 6 is greater than or less than or equal to 0.
Right. So that one had a fraction, or sorry, a radical. So you take the thing under the radical, greater than or equal to 0. Those are the two things we need to look at. So x is greater than or equal to -6. So that's -6 to infinity. So you should know how to find the domain if I give you a fraction or a radical. All right, we okay there? So part C, I asked you to actually compose. G composed with f of 1.5. So that's G of f of 1.5. Make sure, I feel like on the last quiz, a couple of you flipped the order on these. This one, you're plugging it into f first. So if you need to, grab a calculator. You've got f is 3 over x minus 2, so it'll be 3 over 1.5 minus 2. When you do that, wait, am I looking at the wrong?
X is a
Yes, sorry, I was looking at the wrong question. It was -2 over x minus 5, sorry. So -2 over 1.5 minus 5. And that gives you 4/7. So we're doing G of 4/7. So you go to G, and if you plug in the square root of 4 over 7 plus 6, you get 2.5635. Did you get it?
No, how do you type in calculator? 'Cause
So I told you that f of x is -x squared minus 7x minus 22. I asked for f of -5. So that means you replace all of these x's with a -5. So -5 squared is 25, but there's a negative in front of that, so that's -25. -7 times -5 is positive 35 minus 22. So that gives me 10 minus 22 is -12. Problem 19. This is one that it would probably be really beneficial for everybody to pay close attention to. And you are going to have one very, very similar on your test. And this is worth quite a few points because there's several steps here. So I am asking you to find G composed with f and the domain. So this means G of f of x. F of x is 3 over x. So if you plug that into G, that's 5 over 3 over x minus 1. Now, we talked about you can't leave a fraction in a fraction. So what's the fast way to get rid of it?
Multiply x.
Multiply by your denominator, which is just an x. So I take everything times x. That gives me a 5x over 3 divided by x times x is 3 minus 1 times x is just x. So there's my composition. For the domain, you have to look 2 places. The final answer and the first thing you plugged in. Because if you start, you're going to put x in here first. This was a fraction, so we know the denominator cannot be 0. I ended with a fraction, so that denominator cannot be 0. So for the domain, you have to use both of those, so x cannot be a 0 or a 3. Every day.
every time.
It's nice to see you.
Yeah, I see. I see.
All right. Are you okay with that one? So you can do that on your test tomorrow? Problem 20. We just asked for one similar to that, so maybe not that exact problem. So let's say I gave you So this one I asked a lot of questions. I could ask you to evaluate some things. If I said f of -2, which piece would you plug it into?
Second one.
Second one, because it had the equal to. So if you put -2 in there, you get -4 plus 1 is -3. If I ask for f of 0, which one do you plug that into?
First one.
Are you sure? 0 is bigger than -2, isn't it? So you would also plug that into the second one. You get 1. If I ask for f of -10, which one would you plug it into?
First one.
The first one. So you get -10 plus 3 is -7. So I might ask you just to evaluate your function, just testing if you understand which piece you plug it into. And so you're just looking at your domain. I also asked you to graph this one. So we know when we graph these, we have to have a t-chart for each piece. For the first one, what do you have to plug in? -2. It doesn't have an equal to, so it would be open. And then you need things less than that. So maybe a -3 and a -4. So if I plug in -2, -2 plus 3 is 1. -3 plus 3 is 0. -4 plus 3 is -1. -2, 1 is open. -3, 0. -4, -1. It doesn't have a stopping point, so this just continues. Second one, you have to start with -2. It had an equal to, so that one's close. And then I asked you for things greater than that. So maybe a -1 and a 0. So if you put in -2, you get -3. If I put in -1, I get -2 plus 1 is -1. Put in a 0, we get 1. So -2, -3, -1, -1, 0, 1. So it looks like this. So then on this one, I also asked you some questions about the graph. I asked you, where is this graph increasing? Where is it decreasing? Where is it continuous? What's this first section? Is it increasing or decreasing?
Decreasing.
Careful. The line's going down, but when we do increasing and decreasing, we're going from left to right. So as we travel left to right, it is rising. So it's increasing from -infinity. You have to give me the x value to -2. What's this piece doing? It's also increasing from -2 to infinity. Does this graph ever decrease? No. Where is it continuous? So continuous means it's never constant. But if I ask you about continuous, that's saying where can you graph this without picking up your pencil? It's everywhere except that -2, right? So it's everything until -2 and everything after. All right. Let's talk about 21 and 22. Let's graph this one. What's my parent function?
V.
Yep, absolute value of 0, 0, 1, 1, -1, 1. So my parent function looks like this. Let's talk about the transformations. What will the negative out in front do?
Flip over the x.
It's making all my y's negative, so it flips over the x. What's the +4 do?
Left 4.
And the -6.
Left. Or down 6.
Alright, 0, 0, if I flip it doesn't go anywhere. Left 4, down 6. So 1, 1. If I flip it, goes down to -1. Left 4, down 6. Okay, -1, -1. If I flip it, goes to -1, -1. Left 4, down 6. So it looks like this. Then I asked you about the range. This is kind of like the graphs on the front page. You have to draw me a rough sketch and give me like domains and ranges from that. Range is talking about the y's. So from the bottom up, this graph is coming from negative infinity and it stops at -6. So the -6 gets a bracket. So if I ask you for a domain or range, you can look at a graph to answer that. And problem 22. I asked you if this was even, odd, or neither. This is very similar to question number 2, no, not 2, 3, where I asked you if it's symmetric to the x-axis, y-axis, or origin. I think you guys preferred graphs when we talked about these, so everybody grab a graphing calculator and plug this in, please. Bless you. Right. If you use a graph to justify your answer on the test, I would expect you to draw me a picture of what you're looking at. It looks something like this. So assuming I drew my graph well, even is the same thing as symmetric to the y-axis. If I flip this over the y-axis, does it overlap itself?
No.
No. Odd is the same thing as symmetric to the origin. To be symmetric to the origin, you have to flip over both the y and the x. If you do both flips, will it overlap itself? Yes. So this graph is odd. On number 3, I asked, is it symmetric to the x-axis, y-axis, origin? So you have to tell me yes or no for each. So this one is not symmetric to the y. Is it symmetric to the x? No, but it is symmetric to the origin. So you can use your graph to justify those. All right, we have 10 minutes left. What else do you want me to talk about? 23. Good. We should review some of these absolute values. All right. Any absolute value problem, first step is to isolate the absolute value. It has to be on a side by itself. That is the case here. Each side has one absolute value, but it's isolated. There are no other terms. Then we break it up and make 2 equations. The first equation, the only thing that happens is you drop your absolute values. Second equation, you drop the absolute values and set it equal to a negative. For our purposes, all you have to do is run a negative through one side. Doesn't matter which one. So then if we solve this, we can subtract over our 3x, subtract 11, divide by 4, and we get -3. This one, add your 3x over, subtract your 11, and you get -1. You can always check these by plugging them back into the original.
Can our answers just be like that? It doesn't have to be like...
Yes. If it's an equal to, you can just list them. Do we need to do some inequalities to refresh? Remember, your less than is an and, so you should get one interval. Greater than is an or, so we should have two separate ones. What else? What are we struggling with, guys? What else do you want me to talk about before we end class? All right, so problem 20. You had to graph your function. And so it looked something like this. Okay. And so then I asked several questions where it says increasing, decreasing, constant, and continuous. So this first section of the graph, as you go from left to right, is it increasing or decreasing? Increasing, please get that away. So it's coming from negative infinity and stops. You have to give me the x value, which is positive 4. Then what's the next section doing? Decreasing, starting at 4 and going forever. Constant is a horizontal line. We never have that here, so that's none. Continuous is where can you draw this without picking up your pencil? So that's starting from negative infinity. I can keep going. The only time we use y values is if we're talking about a range. So everything else we use the x. So that's when my x was 4. It was an open circle, so parenthesis. Union, pick back up with a closed circle, so bracket, 4, comma, and that one keeps going to infinity. So increasing, you're just breaking where you jump from one, or sorry, for continuous, you're just breaking where you jump from one piece to the next. What else? So the special cases of our absolute values. This says an absolute value, which we know is a positive number, equals a negative. Can a positive equal a negative? No, so that's no solution. This says an absolute value, so a positive is less than a negative. Can a positive number be smaller than a negative number? No, so no solution. This one says a positive number is bigger than a negative number. Positives are always bigger than negatives. So that one is the negative infinity, positive infinity. What else? How do you tell if something is a function by looking at the graph?
Vertical line test.
That's this vertical line test. You guys know how to do parent functions and transformations.
Yes.
How are we doing with the domain stuff? Anything you guys want me to look out or do another problem like? Okay. So you guys need to work this one out and see what we get. this. So is this thing symmetric to the x-axis? If I pull it on the x-axis, overlap itself?
No.
No. Y-axis?
Yes.
Origin? What's it, is it even or odd if it's symmetric to the y?
Even.
Even, good. Where is that function increasing? Negative infinity to 0, give me the x value. And then decreasing?
0 to 1.
Good. Is it a function?
Yep.
Yeah, S is a vertical line test. Alright. What if I said what is G composed with F going to be? So what would we have to do? Over.
Over x plus 3 multiplied by x. On the bottom.
Multiply.
So then negative 2x will be on top. And then 4 plus 3.
So we can't leave a fraction in a fraction. So that's the composition. If I asked for the domain,
X cannot be 0, and then 4 plus 3x cannot be 0. When you minus the 4, so then 3x cannot be 4 divided by 3, x cannot be 4/3.
we have to look back at this original inside. It's a fraction, so bottom can't be 0. And then final answer. So my overall domain, x cannot be a negative 4/3 or a 0. If I asked you for the domain of this, what would you do?
X plus 2.
So it would be negative 2 to infinity. Okay, so test is tomorrow. Look over your study guides. If you need anything, come see me.
So can I put my finger and resume?
Yes.
What are you about to miss it and probably go check in?